A homeowner recently dropped €14,000 on a set of top-of-the-line, triple-glazed windows. She was expecting a completely transformed house.
But after all the dust settled and the contractors went home, her monthly heating bill dropped by exactly €11. €11. Then, the real nightmare started. Thick black mold started growing right next to the brand new frames. Now, here is the absolutely crazy part. She didn't buy bad windows, and she didn't hire a bad installer. She made a massive sequence mistake that tens of thousands of homeowners make every single year.
You're going to learn exactly why new windows so often fail to cut your energy bills, what actually causes that post-installation mold, and the precise steps you absolutely must take before you buy any glass.
Chapter 1. Where the heat actually goes.
Before you spend a single euro on new glass, we have to look at the brutal math of home energy loss. Look at where the heat is actually escaping in a typical pre-2000 detached house. Your walls, they're losing up to 35%. The roof is losing 30%, and just uncontrolled drafts and air leaks take up to another 20%. Windows, they only account for 10 to 15% of total heat loss. So if you upgrade your windows, you're only fixing 10 to 15% of the problem. A massive 85% of your heat loss remains completely unchanged.
Chapter 2. The Airtightness Trap.
If the windows aren't your biggest heat losers, why on earth does mold suddenly appear right after an expensive replacement? Well, it comes down to a totally counterintuitive fact. Your old, rattling, drafty windows were energy disasters, sure, but they were actually doing a critical job for your house. They constantly leaked air, which continuously pulled moisture outside. Modern sealed frames eliminate that draft completely. They're highly efficient, but now all that daily moisture is totally trapped inside. And we aren't talking about a few drops of condensation here. A typical family of 4 produces 10 to 15 liters of water vapor every single day, just from breathing, cooking, showering, and drying laundry. It all adds up to 15 liters of water just floating in your indoor air, with absolutely nowhere to go in a newly sealed house. Here's what most homeowners miss. It's an invisible failure that happens right at the edge of your beautiful new frame. I mean, what actually happens to all that trapped moisture? It hits the dew point. The dew point is the exact temperature where humid indoor air turns back into liquid water the second it touches a cold surface. Usually, that cold surface is the uninsulated wall reveal right next to your new window. That moisture condenses, and if it stays cold and damp, mold inevitably follows. So the mold isn't a window defect at all, it's a massive ventilation failure.
Chapter 3. The invisible frame edge failure.
This brings us to the second major reason new windows let you down financially, even if you bought the absolute top-tier, most expensive glass. It's caused by a thermal bridge. Think of it as a continuous path of cold masonry that completely bypasses your high-tech window glass. In most older homes, solid brick runs straight from the freezing outside air to the warm inside air, right up to the frame edge. That cold masonry acts like a superhighway for heat loss, totally ignoring the $14,000 glass you just put in.
And here is exactly how you get trapped by a cheap installation quote. A pocket installation just wedges the new unit right inside the old frame. It's cheaper, yeah, but it completely hides that thermal bridge we just talked about. What you actually need is a full frame replacement. This takes everything back to the bare masonry so your installer can actually insulate the reveal. If you accept a pocket installation quote without reveal insulation, you are basically guaranteeing terrible thermal performance.
Chapter 4. Trickle vents and the law.
Now this brings us to a topic homeowners usually hate, but that building inspectors strictly demand. Most people think trickle vents look cheap and defeat the entire purpose of a tightly sealed window. But listen to this quote from Approved Document F, which outlines the building regulations for England and Wales. Replacing windows must not reduce a home's background ventilation. Skipping trickle vents isn't just an engineering mistake that causes mold. In many places, it's a direct violation of building regulations.
So, if you push back and completely refuse trickle vents, what's your alternative? Well, to stay compliant and mold-free, you'd need a full mechanical ventilation with heat recovery system, or MVHR. That is going to cost you somewhere between €5,000 and €12,000. Suddenly, those little trickle vents at the top of the frame don't seem like such a bad idea, do they?
Chapter 5. The honest payback and the exceptions.
Let's have a totally transparent breakdown of when and why windows actually make financial sense. If you're buying windows purely for the energy savings, you're looking at a 20 to 40-year payback period. You honestly might not even break even before the windows reach the end of their lifespan.
The real benefits are the immediate noise reduction, the immediate elimination of that horrible cold draft feeling, and typically recovering 60 to 70% of the installation cost in your property's resale value. That is what you are actually buying.
Of course, there are always objective exceptions. Here's when you absolutely should upgrade your windows first. Number 1, if you have genuine, rattling single glazing. The jump from a terrible 5.8 U value down to a modern 1.4 is just massive. Number 2, if you have severe thermal comfort issues, like a room you literally cannot use in the winter. Number 3, heritage buildings where wall insulation is straight up banned, making vacuum-insulated glass your only real option. And finally, if extreme street noise is ruining your quality of life. In these specific cases, glazing absolutely moves up your priority list.
Chapter 6. The correct sequence.
If you don't fall into those exceptions, how do you protect your investment? Simple. Do not sign a contract unless you see these 4 things in writing. 1. Full frame removal. 2. A minimum of 20 millimeters of PIR or aerogel reveal insulation. 3. Trickle vents must be included and sized to regulation. And 4. Demand the U value. That's the U value for the whole window unit, not just the center glass. Because a great piece of glass in a terrible, cold frame is simply a terrible window.
So, let's move to the ultimate roadmap, the definitive 5-step retrofit sequence. This is exactly how you avoid the €14,000 trap. Step 1, fix your invisible air leaks. Step 2, insulate the roof. Step 3, insulate the walls. Step 4, establish controlled ventilation. And finally, Step 5, replace the windows. Windows belong at the absolute end of your envelope upgrade, perfectly sized to match your newly improved building.
The technology isn't broken. The planning almost always is. If you take away just one practical thing from this explainer, let it be this. Before you spend a fortune on glass, get a winter thermal imaging survey done. It only costs a couple of €100 and it will show you exactly where the heat is actually leaving your house. In most older homes, it's going to point straight at the walls and the roof. That survey alone could easily save you from making a €15,000 sequence mistake.
To help you map this all out, there's a free retrofit calculator linked in the description below, along with links for independent consulting if you want an expert to review your specific project before you commit. Now that you understand how to trap heat inside your home for the winter, ask yourself, what happens when it gets too hot? In our next explainer, we'll uncover why highly efficient homes become unbearably hot in the summer and why the sun is almost never to blame. Fix your sequence before you buy.